Hello, and welcome to our session, Let Veritas and VMware Get Your Head in the Clouds. My name is Alex Restrepo. I've been with Veritas for coming up on about 8 years. I started in 2012. By that time, the relationship between Veritas and VMware was already about 10 years old. In that time, we saw the huge shift from physical to virtual. And likely by around 2012, most of you were already heavily virtualized, if not completely. Veritas was, of course, working very closely with VMware at that point. And since I've joined Veritas, in these last 8 years, we've seen another huge shift in the industry, where cloud technologies, both public and private, have come into play, and even serverless technologies and containers are certainly making their mark. All of this creates what we would call a hybrid or multi-cloud world. Now, taking advantage of a hybrid and multi-cloud environment can be daunting. VMware, of course, is making it incredibly easy to manage all of your infrastructure, regardless if it's on-prem, in the cloud, or even containers, from a single interface. This makes it very easy to adopt these new technologies and make sure you're taking advantage of everything that you can. Similarly, Veritas extends its enterprise data services platform across physical, virtual, and cloud, making it very easy to manage data protection, data availability, and insights into that data, no matter where it is in that spectrum. So focusing in on data protection. There's a lot that Veritas does around data protection. We're pretty well known in that space. But specifically for VMware, the experience can be very similar if your VMware environment is on-prem or in the cloud. Some of the technologies we bring to bear for both Veritas and VMware, on-prem or in the cloud, include completely agentless backups, meaning no overhead when it comes to protecting your environment, intelligent policies that understand the dynamic nature of environments so that as servers come online or older servers get deprecated, you're able to keep the environment you care about protected with just a handful of simple statements inside of a query. And lastly, when it comes to restores, they're just as agentless, but important. They can be granular down to an individual file or an entire VM or even dozens of VMs. Now, it's not just us saying these things. We back this up with 195 virtualization-specific patents, as well as a number of certifications with VMware, including being vSAN certified, VMC validated, and vRealize certified. All of these patents are really just part of an ongoing relationship we maintain as an advanced technology partner with VMware. To show us more about an environment being protected in the cloud, our own John Hink is going to give us a demonstration. So John, why don't you show us what we can do in the cloud?
Hi, I'm going to talk to you a little bit about how we use NetBackup to protect your VMware environments.
First thing you need to do is add a VMware server. It's pretty straightforward. Just need to know the host name, credentials, and pick a backup host for validation. Once you have to authenticate with the box, it's going to go through and discover all the VMs in the environment so that you can configure protection for them. But first, none of this is going to work very well if I don't have storage set up. So how about we do some cloud storage? All I need to do here is configure the cloud provider I want to use. Select them. Next, I can pick my region I want to go to and storage class. And finally, I just got to pick which media server I want to host this. I'm going to pick VM21. It's always a good idea to give it a name. Kind of tells you a little bit more about where it's going and what it's doing. So I'm going to just call it Amazon, and I'm going to say Cloud Catalyst. And that helps me know where I'm setting my stuff. Finally, this is the hard part of enabling Cloud Catalyst by checking a checkbox and telling it the volume mount location you want to use. If you were doing this with an appliance, the experience would be just the same. Next, all I need to do is put in my credentials, no peeking, and there's advanced settings I want to set, all sorts of stuff from encryption and whatnot. So if I want to do encryption, I got KMS encryption. I simply just have to provide the key group from the encryption server, and then I can select additional media servers that can write data to this pool. After that, all I have to do is just confirm the storage server properties and click Finish. Now what it's doing right now is it's going to set up the storage server and get it all prepped to run the deduplication services that we need to write to the object storage. Once these objects are deployed on that server, it's a simple matter of going in and setting up essentially which bucket we want to use. We're going to call that a disk pool, so I can pick whatever name I want to put in there, simply a logical name, and then I can pick the storage server, indicate that again, and I need to make sure I go through and use the bucket. I can use an existing bucket, maybe I already created, but if I haven't created the bucket, I can just go in here and pick the bucket and designate which region I want to use. Now keep in mind the bucket names have to be lowercase and can't use certain characters. If I do that and I hit next, I can also do replication target, but I'm not going to now. Configure this, it will actually finalize the deployment of the storage service, and then all that's left to do is add a storage unit that I can use as a logical target for my jobs. With that taken care of, let's create a protection plan and assign protection to a virtual machine. Creating protection plan is pretty straightforward. All I need to do is go in and say to add one. Pick a name that's descriptive of what I want, and in this case I'm going to not only set up a protection plan to do a local backup, but also to send a copy to the cloud from the same server. Scheduling is pretty straightforward. I can pick in this case, I think those all look good, except for I want to make sure I make that copy to long-term retention right away. Once I decide what I want to do, I have to remember to go into the start window and set that up. I'm just going to make it wide open and frequency-based. Click Save and Next, and I pick my storage. First copy is going to go to local MSDP on VM07, and the second LTR copy is going to have VM07 send it to the cloud. Same machine again. After that, a few options I can do. Click Next. Click Next if I don't want to assign granular permissions, and Finish. And I've created the protection plan. The next thing I need to do then is go find a VM that I want to protect. And I can assign protection by simply selecting that machine, clicking Add Protection, pick the protection plan I want to protect it with, and selecting Next. Review my things, click Protect, and it's done and all taken care of. That machine will get protected and will follow that policy. But say you don't want to have to micromanage VMs and make sure they get backed up and all that sort of stuff. So for that, we have intelligent VM groups. With intelligent VM groups, it allows you to define criteria that are used to automatically select VMs and make sure they get the protection that you want them to get. Simply do that by using a query based on various criteria that you want to check, and you can cascade them and put them together. In this case, I'm just going to use tags. I'm going to tell everyone who wants their VM to get backed up to make sure they tag their VM with a tag that says back me up. That tag then will get picked up off the VM automatically by NetBackup whenever the policy runs. So for protection, I can again just go in and pick one of my protection plans I've defined, and simply have to assign that protection plan. And like I showed you earlier, you can have different criteria and different things that happen in those protection plans, and it will automatically apply that protection or that series of locations you want that backup to go to any VMs that are discovered that have the defined tags. Let's say I just want to run a quick backup without having to do any special effort to do it. And what I'm going to do with this one is I just search for this VM in the infrastructure that was automatically discovered, and I'm going to do the new backup now feature, which means I can take a protection plan and back it up right away. All I have to do that is pick the protection plan I want, say VMware Backup 2, and click Start Backup. Go in here and I can see the job run. It's relatively straightforward. The job will run. It does a snapshot-based backup of the VM, and what it's also doing is using an accelerator track log, which means that if you were to rerun that job right after that, it would help optimize reads for synthetic fulls and high-performance backups. If I want to do a recovery point from one of the backups of this VM, I can do a couple different options. I can restore. This particular VM's got a backup, as you can see, one is local, one that's been sent to the cloud. When I do a restore, I can do an instant access virtual machine. I can restore the virtual machine, or I can even just download individual files and folders from the machine right onto my computer that I'm running the browser from. This works essentially by using direct access to the dedupe storage to do file level recovery right out of the VM image. All I need to do is patiently wait, click on add, and it will allow me to browse basically the file system of this client. This is just a Windows box. Let's pick a few random files just for the sake of it. And we can recover a whole directory or individual files. I just got to select them just like you would expect. Click add. They show up to the list of things that are going to be recovered. I run this and it prepares the files. I have to simply just click download. It will download a zip file with everything that I indicated in it. Those files will be in a standard zip file, which allows me to pretty much recover that to any platform whatsoever. So it's a nice and easy way to get quick access to files. And consider this if you got like a VM admin who wants to do a self-service. You can use RBAC to give them this access to the backup infrastructure and control that. So the next cool trick we could do, this is again from a build your own environment I've set up. I'm going to recover this VM, but instead of recovering it onto the data store that the vCenter server is using, I'm going to run it right off of our backup storage using instant access. I'm going to give it a unique name just to avoid confusing anybody, and I have to go through and click next, and then next thing I just have to do is start the recovery. What this does then is it again uses the backend storage to present to the vCenter environment a new data store that it can use to run the VM off of. So then you go into vCenter and you can see it's created a new VM. It's powering it on automatically, as I indicated it should. This is a fully functional VM. It would look just like the one I backed up. And it allows me to do things such as recover it. I can recover across infrastructures. I can use it for dev test. I can use it because I just want to try something out, for example, or whatever reason I have. And I can also do extended things too, like I can vMotion it. If I wanted to do a vMotion recovery, it will come online and vMotion in the background while I'm still using it off the back end. And this machine just boots up and it's good to go. And when you're done with it, you just need to click delete and it will disappear. And not only will it pull it out of the vCenter environment, but it will clean up the backend storage. Of course, your backup's still going to be there, so you'll still be able to go back and do it all over again. As you can see here, it's no longer present. It's all cleaned up. And then this is actively cleaning it out, and we're all good.
So we've talked a little bit about protection. Next up, we're going to talk about availability. What do we mean by availability? Well, what we mean is making sure that your applications are available. So that's a loaded term. We don't look at it like an on-off switch, right? We look at it like a dimmer switch. Your application might be powered on, it might be working, but it might not be working at its best. And so it could be dim, and we want to maybe make sure it's bright. Of course, there's always the downside of maybe it's completely off and it needs to be up. All of those are concerns. But importantly, there's one last thing that we really focus in on, and that's the application layer. If you look at infrastructure management, that's very important. And so you're going to have high availability when it comes to your infrastructure. High availability servers that are clustered and fail over automatically. But what happens if your application fails by itself? It core dumps, a user error, somebody shuts something down. Either way, but if the application fails by itself, it won't necessarily trigger anything for an entire server to fail over. That's where Veritas comes in with our InfoScale solution. The latest release of InfoScale 7.4.2 gets that much better when it comes to automatically protecting environments if they're on-prem or in the cloud, making sure your application, regardless if it fails alone, doesn't fail quietly. To show us something about these capabilities, we have our own Joe D'Angelo. Joe, why don't you show us a little bit of an environment failing over from on-prem to the cloud?
Thanks, Alex. I am delighted to be here at VMworld 2020, even if it is from the comfort of my home office. My name is Joe D'Angelo, Availability Practice Lead and Distinguished Engineer at Veritas. And today I would like to demonstrate how, with our flagship high availability and disaster recovery solution InfoScale, you can simplify the transition of workloads from on-premises to the Azure VMware solution. Now, before getting into that, however, I do want to take just a few minutes to discuss with you the core capabilities of InfoScale and how it is able to ensure the ordered recovery or migration of your critical applications. InfoScale as a technology has been in the market for over 30 years, providing software-defined storage, application resilience, and workload automation for the most critical services across the globe. Irrespective of the industry vertical, be it government, healthcare, or manufacturing, InfoScale addresses the most important business needs facing enterprises today. These include mitigating risk, reducing cost, growing market share, as well as improving productivity. We are able to achieve this by providing an OS-independent as well as storage-agnostic platform designed to address the most stringent RTO and RPOs. So, whether it's recovering a single database from a physical host to a virtual machine on-prem, or a multi-tier heterogeneous service spanning different operating systems or hardware technologies, InfoScale delivers a level of HADR automation otherwise unattainable. Moreover, this capability transcends the hyperconverged as well as public cloud ecosystems, such that full autonomy of your applications is no longer beyond reach. Now, for the purposes of this demonstration, we'll begin first with an example of a typical on-premises HA environment, followed by a configuration in AVS, as well as failover between the two. What's most convenient is that the options afforded you in your physical data center for VMware are identical to that of an AVS deployment. InfoScale, or more specifically VCS, is designed to monitor not just an individual application, but rather all the necessary infrastructure elements supporting it. As you can see from our Java GUI, these resources include virtual IPs, NICs, and storage volumes, as well as any subsequent service the application may require. In the case of this Oracle example, that would mean the net listener. When considering an ESXi environment, however, what's most consequential is the manner in which the storage volumes are configured in VCS. While you do have multiple options, the two primary methods are with either our VMware Disk Agent or the use of flexible storage sharing, both of which can be used in local HA and DR configurations. So let's take a look at the differences. From the VMware console, we have three separate VMs defined: Joe Linux 01, Joe Linux 02, and Joe Linux 03. It just so happens that 01 and 03 are part of the same local cluster, while 02 is a single-node remote cluster. Let's take a quick look at the storage layouts. As you can see, there are a number of VMDKs assigned to the VMs, but let's focus specifically on the 5 GB disks. From the listing, you can see that the devices are each stored directly with the VM in the data store. As far as the secondary SCSI controller is concerned, it can have bus sharing set to none, virtual, or physical. The only caveat is that use a SCSI controller separate from the boot device. From Joe Linux 03, you can see that similar 5 GB disks have been provisioned and are also stored locally with the VM and are in fact unique and not shared. From the server side of the command line, let's now take a look at how the host as well as InfoScale identifies and shares the local disks. First, we'll look at all the disks mapped to each VM using the lsscsi and lsblock commands. We can now see a number of SCSI devices, and given what we glean from the vSphere console, we know that these are the 5 GB disks attached to the second SCSI controller. We're now able to correlate the VMDK configuration with the devices seen by the operating system. Now, once InfoScale has initialized these disks, that is formatted such that a Veritas file system or VXFS can be created, the devices themselves can then be exported to all other participating cluster nodes. Now, this is entirely transparent from the applications themselves and requires no augmentation or reconfiguration whatsoever. InfoScale, and in this case more specifically our dynamic multipathing feature, assigns an enclosure-based name to each disk. Now, when using FSS, this results in an easily identifiable hostname prefix corresponding to the source node of the device, which can then be associated directly with the native OS name. The other distinguishing characteristics of FSS is the online remote or online exported designation for each disk. As you can see, Joe Linux 01 devices are online exported shared, while the Joe Linux 03 disks show as remote. You can also see that we have an even number of devices exported as we do remotely visible on Joe Linux 01, 12 each. A typical Oracle setup, however, will use multiple disk groups, so you can easily filter on the DG name to show which devices belong to which. Each volume that you create will then be comprised of 2 mirrors, one from each disk. This provides the necessary redundancy should a cluster node ever go offline. An alternative way to view and manage these types of deployments is via our VIAM or Veritas InfoScale Operations Manager dashboard. Included with VIAM are a multitude of configuration tools, both for storage as well as availability procedures. Let's take a look at the user interface. Once logged in, you can choose from a number of different perspectives. Let's begin with the server view. Once selected, you can pick from any one of the registered hosts. As we expand the primary cluster organization, we will select Joe Linux 01 and view the disk configuration. As you can see, the disks both local and remote are displayed along with their size, media type, and disk group name. Further to the right, the FSS status, which is listed as one of the extended attributes, is also visible. You can also view both the local as well as remote resources associated with a host the same as you could directly on the node of the cluster. As was the case with the CLI, you can filter the results based on the disk group name, which in this case is either Aura Data DG or Aura FRA DG. The same disk perspective is rendered, now simply being filtered on a specific disk group. Looking further into the storage configuration, we can expand volumes and see what resources have been allocated, that is, what file systems have been created. The disk view looks very similar as one would expect. Beyond the storage config, VM also provides a view into the applications that are running on each host. Simply expand Applications and select the particular type, in this case Oracle. From there, it will display the configured instances both on the local cluster, 01 and 03, as well as the remote cluster node, 02. Once you have selected the instance, you can then navigate through the various tabs, table spaces, files, disks, and even replication status if it is configured with VVR, or Veritas Volume Replicator, which in this case it happens to be. You can also see the correlation between the VCS console and the instance itself, indicating that the database is running on 03. Let's now for a moment take a look at the Volume Replicator configuration. This is a very important facet of a VMware to AVS DR solution, as it provides the means for a granular application-level recovery from on-prem to the AVS or public cloud, regardless of the underlying storage. VVR is entirely IP-based, maintaining write order fidelity on a per DG basis. VVR has two main components, a primary volume and a replicator log, shown here for the Aura Data DG disk group. As was stated earlier, the two primary storage configuration options with VMware and AVS are flexible storage sharing and our VMware Disk Agent. Let's take a look now at an AVS setup that is configured to use our VMware Disk Agent. First, we'll need to log into the AVS vCenter dashboard. From here, we can see we have two virtual machines active, InfoScale VM4 and InfoScale VM5. Let's take a look at the VMDK configuration and compare it to the FSS setup. As you can see, we have 11 total disks allocated to VM4. By comparison, when we look at the VMDKs assigned to VM5, we see only the 100 GB boot disk visible. This is in stark contrast to the FSS setup where duplicate VMDKs had been provisioned. Let's now view the VCS Java GUI to see what the application config looks like. The service group is configured once again to support an Oracle database, but this time the resources configured include 10 instances of our VMware Disk Agent. What this resource does is perform a detach and attach of the VMDKs from the virtual machines by way of the hotplug API. This allows for the movement of devices to support failover on any Linux or Windows-based application, without requiring any specialized storage setup, be it SCSI 3 or otherwise. Let's now initiate a failover of the application. While that is progressing, let's take a look at the disk configuration on the VMs, remembering that all the devices were last attached to VM4. We now see the disks being attached to VM5 and coming online in VCS. Also, you'll notice that all the disks have now been detached from VM4. Here you will notice that the disks have been fully registered to VM5. Meanwhile, the VCS Java GUI will soon reflect these updates and bring the remaining Oracle database resources online. Rounding out our demonstration for today will be the use case of DR between an on-prem VMware private cloud and an AVS public cloud deployment. Expanding on much of what we have discussed so far, this configuration involves two independent clusters fully configured with the VMware Disk Agent, as well as our volume replicator and global cluster option. Now, I would be remiss, however, if I did not acknowledge that in order for this configuration to behave correctly, you must deploy the appropriate network topology or express route circuit connectivity. That aspect of this configuration, however, is not part of today's demonstration. With our VCS Java GUI open for both clusters, we now see a slight variation on the FSS and VMware Disk Agent topology from earlier. When incorporating global clustering in VVR, service group configuration changes are required. This is mainly in support of the resource types used for VVR. Moreover, the application service group is now designated as a global service group, as indicated by the halo. With the application fully online in the AVS public cloud and VVR fully active between the two locations, you can simply select a remote switch when initiating a failover. VCS will handle coordinating all the recovery procedures for VVR, as well as the applications and local disk resources. Now, it's very important to note that the FSS and VMware disk agent options can be intermixed in this scenario. Truth be told, you could even fail over from a physical host into AVS and vice versa.
So thanks a lot, Joe. Appreciate you taking us through high availability for your applications. Great example there. Next up, we're actually going to go ahead and go back to protection. Earlier, we talked a little bit about what protection can do and has been doing for a while there when it comes to VMware in the cloud. Now we're going to talk a little bit about what's protection doing for me lately. So recently, we released Net Backup 8.3. In that release, we've improved a number of things when it comes to VMware protection. First of all, we've improved the querying speed of your VMware environment. So earlier we talked about how intelligent policies are capable of automatically protecting your environment. That requires querying against the environment to understand what guests you have in your vCenter environment. We've improved the speed of that by up to 50 times over previous versions of Net Backup. When it comes to efficiency, we've also improved how we consume network traffic. We've improved our compression algorithms to make sure that when you're backing up your VMs over network, be it network block device or NBD or NBDSSL, we're improving compression to make sure that's more efficient, speeding up your backups, using less resources, and of course, just making a better experience all around. For those with SQL servers on your VMware environment, we've improved that by having direct SQL mount points that can now be protected with Net Backup. And then lastly, we've improved our integration with VMware's VRO or vRealize orchestration. Now, that last item, I think it's worth double clicking on. When it comes to, we've talked a lot about the hybrid multi-cloud world and how it offers you a lot of options, but of course with more options comes more complexity. But an orchestration platform that's API focused, like VRO, abstracts that complexity, making it that much easier for you to interact and manage your environment, no matter how big it is and no matter how disparate it is. And so, of course, we've directly integrated, facilitating a lot of the functions that you would normally have to do directly in a console from Net Backup through VRO instead, without having to log in. And so this facilitates a handful of things. First of all, of course, it can help automate the process through workflows. Second of all, you can delegate responsibility. Role-based access control will facilitate you giving permissions to protect environments that admins are directly responsible for, delegating responsibility. And lastly, of course, those same workflows can set up automation that facilitates a much easier experience for everyone when it comes to data protection. To show us what we're capable of doing when it comes to VRO, our own Luigi Curavilla here is going to take us through some examples of what we can do there. Luigi?
Thank you, Alex. Let's go and quickly deploy the Net Backup plugin into vRealize Orchestrator. I've already extracted the files. They're in the standard VRO package format. So within VMware vRealize Orchestrator, let's go to the Packages tab and then click on the Import Package. It's the first button up top. Click on that. It opens up the file system browser, and here's the package file that we downloaded. Let's click Open, and it begins processing the file. I'm going to click Import over here. This is because I had already downloaded the plugin on the system before, so all these elements come unchecked. Let's select all, and then import again, so it'll override and import them back in. Once all these elements are pulled in, we'll go take a look at them. They'll create folders under Actions and Workflows and Configuration and Resources tabs. So first off, let's go to the left tab over here, click on Workflows, and let's browse some of the workflows. So under Net Backup, a folder, you'll see Workflows, and under Workflows, VMware, so select that, and under VMware, here's the Net Backup workflows that we just pulled in. They allow you to back up and restore agentless file restores, both to the original host as well as an alternate host. We also have another folder which allows you to back up and restore the VM in its entirety as well. Now, let's go over to the Actions tab. These are all the action elements that got imported. There's a list of them. Next, let's go to the Configuration tab and take a look at there. So, under Library, we'll see the Net Backup folder, followed by the mappings and the master servers. The master server folder has a template master. This template is what we will duplicate to create additional master servers in the configuration. The mappings files is where we will associate them to the vCenters. So, without further ado, let's go and configure a master server. So plugin configuration really breaks down into two tasks. One is adding the NetBackup master server and the vCenter servers into the configuration tab of the plugin. The second involves running a couple of workflows that set up a mapping between these two entities. We have a couple of decisions to make. First one, we need to identify a username that has administrator level privileges within the NetBackup application. The second is choosing the authentication method. You can use the operating system username and password, or you can use an API key. I would recommend using the API key. So now, with that out of the way, let's go back to our template master. So let's go ahead and define the master server entry in the plugin. So right-click, duplicate element, and let's go ahead and change the name of the master server here. There we go. Click Submit. And next, here's our entry. We're going to go to the Workflows tab next, and under Workflows, Library, go down to NetBackup, and the Configuration folder. So here we have some configuration workflows. We're going to choose the Configure Master Server workflow, and then let's highlight that and click on the play button. This will begin our workflow configuration step. Now we have some questions. So here's the master server name and a couple of questions. What's the version of the master server? And also, do we wish to use the API key or password-based authentication? So I'm going to go ahead and choose no for the 812. I'm using a newer master server. And then for API, I'm going to go ahead and choose yes. So the username would be someone who has administrator privileges within NetBackup. And for API key, that'll be something we generate out of the web UI in NetBackup. The endpoint URL needs to be updated to reflect the master server name. So let's go do that and click Next. This prompt is asking us, hey, do we want to overwrite the configuration if it already exists? Say yes and submit. And this will run the workflow. When you see the checkbox green check appear on the left, we know that our workflow has completed. On the Logs tab is typically where you'd find any diagnostic information that helps you troubleshoot. So let's go and now configure the VMware assets. So to do this, we'll go back into the configuration section, and within there, under Library, NetBackup, we have Mappings folder and VMware and AWS, a couple of choices. For the type of asset, whether it's VMware or AWS, we would go and create a subfolder designating that resource. This mappings section in the configuration contains rules for the asset attributes to determine the master server that we would link them with. So under VMware, we're going to go ahead and create a folder. So highlight VMware, right click on that, and we are going to choose new folder. Over here, we'll go and punch in the vCenter. So I'm going to use an IP address. You can also use a host name. So let's punch in the IP address and click OK. Now that we have this created, let's go and link it to the master. So for that, we'll go to the Workflow tab, and under Workflows, we're going to go to the Create Master Server VMware Mapping Workflow. So let's go ahead and click play, and now we'll get a couple prompts. There we are. So first off, we have the master server that we wish to create a mapping with, and the vCenter. Let's go and choose the vCenter entry that we just added. We also have the ability to create a mapping from the master server directly to a data center as well. So let's go and choose that option too. This way, we will create multiple mappings in one go. We can always rerun the workflow to create more mappings later. Let's click Submit and give it a few seconds. Wait for the little play icon at the lower bottom of the screen to go to a green check. And once it's done, now let's go and take a look at the configuration. Let's expand the configuration for the entry we just created. And now here you'll see that the mapping has been created between that vCenter and the NetBackup master, as well as from the data center back to the NetBackup master. So that wraps up configuration. So now we've created the master server entry as well as the VMware mapping. Now, there's also one other thing that I would like to share. We have a configuration check workflow. This workflow will allow you to check the entire configuration, whether it is for one master server or multiple master servers. I'm going to skip running it, and let's go right into protection. So now that we have configuration out of the way, let's dive right into protection. So I'm going to open vRealize Orchestrator and go into my library, and from there select workflows. Let's go ahead and select the NetBackup workflows. Let's type NetBackup. And once that's done, let's go and also type in VMware. Okay. Let's choose workflows as well. So now we have the workflows that we imported from the plugin. I'm going to go into a full VM protection now, which basically is choosing the Protect VMware VM with NetBackup workflow. So go ahead and click Run on it. And this now allows us to go and choose the virtual machine. So let's go down into the data center, pick a data center, and then find a VM inside the data center. Let's choose London for now, click Select, and this is going to query NetBackup and list all the protection plans that are available. So let's go and select Daily, and that's pretty much it. Let's go click Run, and this will add London 100 to the protection plan. Let's wait for the workflow to complete, and that's about it. It's complete. Now, let's go and do a restore. Restoring a VM is equally easy, so let's go right back where we were. In our library under Workflows, we're going to choose the Restore VMware VM with NetBackup, and this will allow us to do a full VM restore. So let's go ahead and select Run, and this will now help us choose the VM that we wish to restore. So let's go and browse that, look for that London VM we just protected. So let's go back into the data centers, under London, and look for the VM London 100. There you are. Let's go and select it. Now it's going to query NetBackup to find the available recovery points. So let's pick one of those recovery points. And we have a few choices. Do we want to overwrite the existing VM or restore into a new VM? Well, we need to provide a name for the new VM if that's the choice. We could also have the option to power on the VM after restore, or even remove its network interfaces. Let's power on the VM and let the network interfaces stay. Are you sure? Yes. Let's go. Click Run. This is going to fire off the workflow, and now here we are. Right now it's waiting for the job to start, and then it's going to go into a loop and check the status of that job. I fast forwarded, and here's a job has been complete. So it's not every day that we wish to perform a full VM restore. We need the flexibility to perform individual files and folder restores, And that too without having to distribute agent across the VMware infrastructure. So let's go take a look at that. In the VRO Java console, let's go ahead and select the Workflows tab. And under the Workflows tab, we have NetBackup. Expand that. We'll have the Workflows subfolder underneath it. And under VMware, we have some agentless workflows under 8.2 and later. We have a couple of options. One's an option to send the files back to the original machine or to send them to an alternate machine. For now, we're going to send them back to the original machine and choose that workflow and then go up and click play. Now we have a few more questions. Hey, which machine do we want to recover? So let's go and select that from our VMware infrastructure. So as soon as we choose the machine, and then we'll have a few more questions which kind of walk us through where the files needs to be recovered to the same directory or to the same file name and so on. Give it a few seconds here now. Once we discover this machine and the recovery points in NetBackup, the machine name will be populated here. There we go. Let's list the recovery points, and there's a couple, and let's choose the first one. For search, I'm using both so that the search criteria can be searched in files as well as folders. This is the base path for the search. So let's give it a folder name. And I previously backed up a file called Anaconda. So let's go and punch that in over here. So you must be wondering the search. Clicking that yes radio button initiates the search. So let's click that. And that's the results from our file catalog. So let's go ahead and click next now for the remaining questions. We have, hey, what directory do you want to recover to? Let's keep it the original. And we need to provide the OS credentials here. So let's go and punch in the operating system credentials. And once we're done, we'll go ahead and click next. Recovery options. Do we want to overwrite the file or do we rename the file on restore? We're going to overwrite it and click next. Some additional recovery options where we choose the backup host or the data store and the transport path. Let's click next. And the final confirmation, are you sure? Yes or no? And let's go for it. Now that we've clicked submit, this initiates the workflow. At this point, a restore job would be submitted in a backup. And here's our workflow. Basically, it's in a loop checking to see whether the job has been initiated in a backup yet or not. It'll stay in this loop and keep checking on the job status. So I'm going to go ahead and fast forward over here. The job has been completed. It's denoted by the green checkbox on the left at the bottom. And that's it. Agentless single file restores. Now that we've done that, I want to show you one more thing. Previously, I showed you how we could take a VM from your infrastructure and add it to a protection plan so that it could be scheduled for protection. This time, I'd like to actually show you how to go and do an immediate backup right away. So in our library in VRO, under Workflows, select the Backup VMware VM Now with NetBackup. We commonly call it Backup Now. Click Run and choose the VM that you wish to protect. Let's go browse our VMware infrastructure. Let's go to a data center and let's drill down and select a VM. Let's use the same Red Hat one from earlier. Let's click select, and now it's going to query NetBackup to find the available protection plans. Here's the listing. Let's go and choose daily and click run. Now that fires off that workflow, and here's our job. Now we're basically looking and checking NetBackup to see if the job has been started there or not. Once it's started, it'll continue looping till the job exits. So let's go ahead and fast forward again. And this should, once it's done, it'll pretty much all go to a green status and the job would be marked as complete. That wraps up our segment on the plugin. Now it's back to Alex.
Thanks a lot, Leegee. That's some powerful stuff right there when it comes to VRO and our integration. Appreciate that. As we've shown, VMware provides a fantastic control plane for your hybrid multi-cloud environments. Similarly, Veritas extends its enterprise data services platform across all of those environments, on-prem and in the cloud or anywhere in between, making it easy to manage data protection and availability, making sure your systems are there when you need them, and if need be, are well protected from anything like ransomware or any other types of attacks. Together, we're able to provide this from an API perspective, something that VMware is of course focusing in on, making it that much easier to understand and control your environments. I appreciate your time. For more information, email us at vmware.alliance@veritas.com. Thanks very much and have a great VM world.